So hello everyone, today in this video we are going to discuss about the acceleration due to gravity, that is small g, and that is universal gravitational constant capital G. So as we know, the Newton's given, the formula given by the Newton is F equal to G m1 m2 upon d square. Okay, so this is called Newton's law of gravitation. Okay, so this formula you can see here. Here is a capital G. So this capital G is called universal gravitational constant. Okay, so when we put the value of m1 equal to 1, that is mass of the first body is 1 kg, and mass of the second body m2 equal to also 1 kg, and if two masses, this is m1 and this is m2, if these two masses are separated 1 meter distance, or you can say unit distance. So now you have to put this value in this given equation, then its value becomes m1 equals to 1 unit, and this m2 also 1, so 1 into 1 by 1. So you can see here, this value becomes g, and so you can write here f equal to g. So in this case we can see here, when we put the value of m1, mass of the first body is 1 kg, mass of the second body is 1 kg, and these two masses are separated by a distance 1 meter. You can say unit distance apart here, and the force of attraction between two unit masses. So these are the two unit masses, and these two masses are separated by a unit distance apart. Okay. So when we put this value, then this value of g, at that time the value of force of gravitation is called this gravitational constant. Okay, this is nothing, this is just a force of attraction between two bodies. Okay, when we put the value of m1 and m2 and distance equal to 1 unit, so at that time the force of attraction is called this universal gravitational constant. But in this case you can see here, acceleration due to gravity, the uniform acceleration produced in a freely falling body due to the gravitational force of the earth, or you can say, if we take the value of g in case of earth, we can mention over here for the earth. Okay, and its different value for the respective planets, or you can say for earth is different value. We have 9.8 meter per second is value of g, acceleration due to gravity, and for the moon, for the sun, it's all have different own value. Okay, so in this we are especially talk about the earth, so its value is 9.8 meter per second square, the value of small g. Okay, this is the uniform acceleration in the case of freely falling body. Okay, at that time the gravitational force is called this acceleration due to gravity. And now if we call our notation, so generally acceleration due to gravity is denoted by a small g, and as we seen here, universal gravitational constant is denoted by capital G. Okay, so these two are the basic difference. And another one is acceleration due to gravity, that is small g is variable quantity. Okay, its value changes according to the, when we move from center of earth to the its equator and along to the pole. So its value is variable according to their radius or according to their distance. But you can see here, universal gravitational constant, this value g, its value is always constant. Okay, and its value is, you can see here, 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so how this unit is become? So if you put the value of this m1 in its SI unit, m1 is equal to kg, and this is also in kg, and distance is in meter, so meter square. So this is g and f. So if we calculate the value of g, then it can be calculated. This is Newton, so Newton meter square. This goes over here, and kg square. So this, the value of this capital G becomes 6.67 into 10 to the power minus 11, and unit is Newton meter square per kg square. If you cannot remember the unit, you can also calculate by the placing this individual its fundamental unit. Okay, so in this way we can see here its SI unit is meter per second square, but the universal gravitational constant SI unit is Newton meter square per kg square. And we seen also its value is 9.8 meter per second square, and its gravitational constant, that is capital G, is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So these are the basic differences between the acceleration due to gravity, that is small g, and universal gravitational constant, capital G. Okay, so basically these are the main difference, so you have to remember it. Okay, so thank you very much. Thank you everybody.